Austin.
That was great. Most audiences takes a couple of rounds.
It does. Every audience takes more than one try. So congratulations. From Microbe TV, this is TWiV, This Week in Virology, episode 500. Today is June 29th, 2018. I'm Vincent Racaniello, and you are listening to the podcast all about viruses. I'm so excited to be recording today in Austin, Texas, at the University of Texas. We are guests of the university, and it is so exciting to have an audience watch us do our 500th episode. By the way, each of you has a sticker on the seat there, a special edition TWiV 500 sticker.
And a special extra gesture, we did not peel off the backing and put it face down like your chair.
And let me introduce the incredible hosts of TWiV in order of when they joined the show. On my left, the person who started TWiV with me, Dixon de Paume. Hello, Dixon. Are you speechless?
I'm touched. I'm really, no, they already knew that, but I mean, I am moved emotionally by this turnout, by the response, by the fact that this is number 500. I'm incredulous. I don't believe that it's 500. It doesn't feel like 500. It feels like 50. It's remarkable that this should happen.
Thank you for joining us.
It's my pleasure.
To Dixon's left, the third person who joined TWiV after I realized that Dixon was going to do a lot of traveling on days that we were recording. Be nice to Dixon. Alan Dove.
Great to be here. And I should mention that it is currently 37 degrees C, 98 Fahrenheit outside, partly cloudy, and there is a heat advisory in effect for this afternoon.
Thank you, Alan. Thank you. Alan, of course, is from Western Massachusetts. After Alan, we had a nice team, but we wanted to do more. So we added who at the time was the University of Florida, Gainesville, Rich Condit. Welcome to TWiV. Rich, of course, is an emeritus professor residing in Austin. How about that? And finally, last but not least, from southeastern Michigan, Kathy Spindler.
Hi, everybody.
So that is our TWiV team. And I would be remiss not to tell you that happy birthday, Rich.
Today is Rich's 500th birthday.
We have a card for you.
Oh, no kidding.
Surprise, surprise.
Oh, yeah, this is great. I open it now.
Yeah.
So 2 years ago, we planned this. Chris Sullivan called and said, we want you here for the 500th. And we counted ahead, and it landed on Rich's birthday. With no messing around with the episodes or anything. It was really remarkable.
Hey, Ray, I got a birthday here. You got it here. That's cool. Thank you very much. This is wonderful.
Mission Control, we have a birthday, and it's an astronaut.
And so nobody else is going to be crude enough to say it, so I'm going to tell you, this is a big one. This is 7-0.
Whoa!
And I'm happy to be here because the alternative is...
All right, we have 3 guests for you today. You can see there's an empty chair for them. But
It's not for Elijah. We're not doing this today.
But before that, I want to tell you a little bit about science podcasting. So in preparation for this, I looked into other science podcasts. There aren't many that reach 500. So for example, the Astronomy Cast is at 496. People Behind the Science, 454, The Reality Check, 502, The Skeptic's Guide to the Universe, 675, This Week in Science is 675. And then I found an article by Lewis Mackenzie, who is a science podcast enthusiast over in the UK. He has actually a website and an article. The website is called A Big List of Science Podcasts. And there are a ton of them, way more than when we started this 10 years ago in 2008. And most of them don't number their episodes. So I couldn't figure out how many they had. I wasn't about to go through them. But Lewis cataloged 952 science podcasts. Of those, only 5 had more than 1,000, and 17 had more than 500. So we're in really good company here, and it's because of these individuals that we've reached 500, because I may be a taskmaster, but if it's just me, there's no task. So thank you very much for doing this.
Vincent underrates his contribution to this because he motivates the whole thing. I'm just, a Google Doc goes up on Wednesdays, and that's my assignment for the week, and I do my homework. If it weren't for Vincent, none of this would happen.
Rich calls it cramming on Thursday night.
As opposed to Alan and I, who might be doing it on Friday morning.
Friday afternoon.
And as opposed to me, I don't do it at all.
Or maybe right now, right?
Yes, I'm working on it.
That's okay. Whatever works. So I asked Lewis, what was the first science podcast? And he said, that's a hard question because podcasting technically only began in 2004. The technology, which, if any of you know what an RSS feed is, it's a way of checking websites that get updated. In 2004, was figured out, or around then, how to include an audio file in an RSS feed, and that became a podcast. So there are lots of internet radio shows before 2004. The first one on Lewis's list is 1995. It is the Howard Hughes Medical Institute's Holiday Lecture Video Extras. It's not a podcast, but
because in 1995, who else could afford to put audio
That's right.
on the internet?
And then the 1998 astronomy. This one, Pulse of the Planet podcast, which started in 1998, has 6,000 episodes. That may be a daily one, right? Some of the other ones, 2001, NASA had a podcast, had 1,000 episodes. The Naked Scientists, they're at 663, and they began in 2004, the official year of the podcast, and then a few others. So Lewis tells us that TWiV was the 137th oldest science podcast, if you count all the way back to 1995.
We're not going to make that our tagline.
But if you look at the number of episodes, we are number 22, on the whole list of total episodes. And he says there are daily podcasts there you compete with, and that's not really quite fair. So that is where we lie. We are pretty good in terms of science podcasts. As many of you know, I do other podcasts as well, and they're far fewer, but they are steady because I do the same with them as I do with TWiV. I said we have to release on a schedule, either weekly or twice a month or once a month, because that is one of the recipes for success, is to be regular in your release so that people expect you at a certain time. People tell me, for example, they download TWiV on Sunday night for their Monday commute. So if you disappoint, they will leave. So regularity is important, and so that's one of the reasons.
That's true for a lot of things.
Yeah.
All right, so that's science podcasting. I'm going to come back to Lewis later. He'll be my pick, actually. We'll talk a little bit more about what he has to say about science podcasting. Now, we have 3 guests, as I said, and the first I'm really happy to welcome. She's the founder of Immunize Texas. Please welcome Jinny Suh. Thanks for joining us.
Thank you for having me.
I found Jinny several months ago when we were talking about vaccines on TWiV, and there was an article about He Who Shall Not Be Named, the famous anti-vaxxer, and her name was mentioned in it. And so I immediately stalked you and found you, and I said, could you come to our 500th episode? And Jinny, you graduated from Columbia Law School.
I did.
We are comrades.
Yes. I actually looked up all your bios, and I'm connected to all of you in some way because I got my master's degree from University of Michigan.
All right, go
I also married a Floridian whose sister went to University of Florida, and then, of course, the Columbia
How about Dixon? Columbia, right?
Columbia.
Yes.
And Alan,
Nice to
Columbia,
meet
too?
you.
Yeah. All right, very good. What brought you to Texas?
I was working as a lawyer in New York, and after 5 years of doing that, I decided I was done. And it was also about the time of the recession, so my husband and I were looking for a place to land, and we ended up here, and we've stayed since. So that was in 2010.
Yeah, there's a lot of people who look for a place to land and wind up in Austin. You know?
It's a great place, but don't move here. Don't do that.
Last
We're
one in
full.
shuts the door.
Yeah, exactly.
Yeah, we heard the statistic that
City is closed.
today there are 120 more people here than yesterday.
Right.
Yes, and I think it was even higher a few years ago, something like 200
Every
people.
day, 100.
And,
Every
and
day.
nobody's leaving?
Yeah,
This is a problem.
yeah.
So, Jinny, tell us, what is Immunize Texas?
So we are a grassroots organization that supports pro-vaccine legislation mostly, but we also just try to increase education about vaccines within the community. I'm sure we'll get into it, but Texas is not in a good place in terms of vaccines and vaccine exemptions. We're one of the worst in the country, and most people don't know about that. They are blissfully unaware, and a lot of times they find out once they've had children, and that is unfortunately not going to change things. You know, if people are ignorant of the facts and of the situation, we're just going to keep going down this very treacherous path. And unfortunately, a lot of experts predict that we might be the place where the next big outbreak will happen, and my job is to hopefully prevent that.
Now, as a lawyer, what inspired you to take on this particular issue?
Honestly, I am like what I just described. It was becoming a mom and not knowing about the vaccine exemption loophole in the first place until I had kids and had to take them to the pediatrician, and finding out that you could opt out of vaccines in Texas. And I guess the lawyer part comes in because I can't keep my mouth shut. So I quickly took to
Neither
social
can we.
media. Yeah, this is a good group to be in. I quickly took to social media and started posting about it, and that's how, through an alumni friend of mine, met up with the Immunization Partnership and got started on this path.
Great.
So what are the exemption rules in Texas?
In Texas, you don't have to have any reason at all. You can just file a piece of paper that's notarized with the Department of Health Services, and they give you an exemption.
Wow. No physician input, nothing. Just I
Nothing.
don't want my kid to
Religious
be
exemption.
vaccinated.
Nope. No. It can
there-
just
are there-
completely be reason of conscience.
But there are school requirements for
So when you go to school, the first day of kindergarten is usually where this becomes the issue. You either have to show up with your vaccine records or with this exemption. And if you have the exemption on hand, they will let you in. And unfortunately, the reality is, even if you are missing one of those things because of the state of education in Texas, a lot of times they will let you slide because they need seats, they need bodies and seats to get their funding.
So in that sense, is Texas the worst in the country, to put it one way?
I mean, it's hard to rate that. I don't think we're at the very, very bottom. However, we're close enough that it's not comfortable. And while my job is obviously focused on Texas, I know you have listeners from all over. This is not just isolated to Texas. This is not just even a national problem. This is an international problem. I mean, I follow a lot of the news, and there are cases of measles and even things like diphtheria just popping up all over the place. And, you know, while I said that Texas is probably going to be the source of the next big outbreak, you know, you have certain specific situations like what happened in Minnesota, where you have a very vulnerable population and he who shall not be named visiting and swaying people to not vaccinate, and then a measles outbreak happens.
Right.
Do you know what the number, I'm sorry, go ahead.
No, go ahead.
Do you know what the number is for exemptions in the state, roughly, percentage?
So this is part of the work that we're doing. If you look at the statewide exemption rate, it does not appear very alarming. The reason being, Texas is a huge state, and most people still do vaccinate. However, what we have are clusters of people who don't vaccinate. People who are that fit into a certain stereotype of somebody that doesn't vaccinate. They tend to live together in the same communities. So, for instance,
Usually with a Whole Foods around the corner?
maybe.
Just
it depends.
hypothesizing.
In Texas, it actually is very much more driven by the conservatives.
Okay.
That's the situation here, although it is a bipartisan issue.
Okay.
You certainly have the sort of left, liberal, crunchy granola type of thinking, but
Nothing
you also
unnatural
have...
will go into my child type of thing, yeah.
I think we're moving into a phase now where the political argument has moved and shifted towards being about parental choice. Freedom to decide what gets injected into your children's bodies, which completely ignores the rights of your children to live a happy and healthy life. But that is the
The
flag
government
that
said
they
something
are
was good,
flying.
then it must be bad type of
Well, it's a very it's a fear of big pharma. It's a fear of big government. It's a fear of doctors who they claim don't know anything about vaccines being bought by pharmaceutical companies and injecting your children behind your back. I mean, I see a lot of that.
Do you have any sense for what motivates that ethos? I mean, where's that coming from?
So I guess my plea today for everyone here is that what you can do to help, not only join Immunize Texas or for the other listeners, your local pro-immunization organization, but really just to get the conversation started. Because the reason the anti-vaxxers have gotten so much of the stage is because pro-vaxxers don't speak up. When it comes to things that people are motivated to talk about, vaccines generally fall very low on the list. I talk with clinicians, I talk with scientists, I talk with statisticians, and they generally have an attitude like, well, it's just common sense. Well, common sense doesn't matter anymore. That's not the world we live in. So
Mark Twain once said the most uncommon thing in the world is common sense. So that probably defines it.
Yes, and so to answer your question, I think there's a lot of reasons why people don't vaccinate. I think you had on your podcast someone talking about it earlier this month, and I echo a lot of what he said. You have the hardcore anti-vaxxers, and for them, this is their identity. This is how they define who they are, and so they will never listen to facts, because to admit that they might be wrong, it tears apart everything they believe in and who they are. But what I'm more concerned about are the vast number of parents, generally new parents, who don't have science backgrounds. They might have a degree in English or political science or something like that, and they think they are educated enough to understand scientific papers. They cherry pick arguments, and they end up in these echo chambers where other people who are not vaccinating just keep giving them these alternative facts, we'll say. And it snowballs into them thinking that they are smarter than their pediatrician, than the scientific community, than the medical establishment, and that everything that is being told to them that is pro-vaccine is just a lie, and it's paid by pharmaceutical money. We're all shills. I'm apparently paid as a shill. I didn't know that. That's what happens. And
those checks are never as big as I expected them to be.
Never.
They keep
No.
not showing up.
Do you actually get a check?
No, that's the problem.
I haven't even gotten a check.
And I can't figure out who to call about this
I know.
either.
Yes, exactly. We needed like an 800 number for the pharma shills. But the reason, again, why the anti-vaxxers have been able to do this is because they are active on social media, they are driving the conversation, and pro-vaxxers don't meet them on the same level. And so if you're a new parent, and you can do this at home, go onto Google, go onto Facebook, Google vaccines and see what comes up. Unless you've already been in pro-vaccine groups, the result will probably a majority of anti-vaccine groups and sites. Everything from Dr. Sears, who, yay, he got sanctioned, so yay. I don't know if you heard about that.
Some progress.
Yes, some progress, to Natural News, to the Health Ranger. I mean, there's a whole bunch of very dangerous, very serious misinformation sites and groups out there that are pushing this on people who don't know any better.
So we have a pretty good idea of why you would have started Immunize Texas, but can you tell us a little bit how, and then what does Immunize Texas do?
So in Texas, the situation in Texas was that in 2015, when the Disneyland outbreak happened, that year there was a legislator who proposed the idea of passing a similar bill that would remove that exemption that I told you about. And it's what, I mean, we've always had anti-vaxxers in the state. That's been true since vaccines have been invented. But that move galvanized them and they formed a pack. So the anti-vaxxers in the state of Texas have a pack, and they are funded, they're very well funded by a lot of politicians and political groups. So that year in 2015, when we had legislative session, instead of it just being doctors and researchers testifying at hearings for the Public Health Committee, suddenly you had a lot of parents showing up. And they would go up to the microphone and talk about how vaccines injured their children. And it didn't matter what the bill was about. They hijacked the conversation and they brought emotion to the table. I'm not necessarily going to say emotion's a bad thing, but certainly it shouldn't trump science and it shouldn't trump facts. But that's what happened. So there was a need, there was a void that needed to be filled for the pro-vaccine community to have not just the researchers and scientists showing up, because that doesn't work anymore. You need to bring parents, you need to bring community members. Everyone in this room will be affected if there's an outbreak, whether it's yourself, your children, or even your niece or nephew, or your neighbor's kid, or just a friend. This is not something that can be limited to an individual. This is a community problem, and so we need a community answer. And that's why we formed Immunize Texas, and we've grown. We could still grow more. We can reach more people. And what we do is a lot of, like I said, education. I post every day, or I try to every day. Regularity is probably one of my weaker points, but I try every day to post some kind of an article just to, amplify the signal, let people know, some positive things about vaccines, and also let people know about things like outbreaks that are happening. Because again, you don't know about it until you read about it. And most people don't, it's just not on their radar. But then in terms of session, we organize politically. We try to visit with legislators. We try to talk to them about these issues. We try to bring, like I said, community members. So it's not just about facts. I mean, they have the facts. They know the efficacy rate of the MMR vaccine. They know, the probability of an outbreak happening. They know the exemption rates. But what they need voters to show up and say, I've got your back. And if you vote for science and for medicine and for protecting our children and our communities, I'll cover you. That's what they need. And that's what we're trying to provide.
So how big of an organization is it?
So we currently have, I haven't looked at the latest numbers. We have somewhere in the low thousands of people who like our page. We certainly would love to grow more. And then we have our active advocates. So I think that's a group of about 500 people all over the state of Texas. And then even within that, it's not everybody is available all the time. And we do a variety of actions. It could be everything from just wearing, I brought it, but I didn't bring it up here. We have shirts that we wear sometimes as sort of a promotional campaign, Immunize Texas shirts, or some people get their own pro-vaccine shirts, like Vaccines Cause Adults, things like that.
I saw those.
Yes, I have one. I wore it to Universal Studios.
Great.
That was really
great.
Fun. Things like that. We also try to have, when there's the right time, postcard writing campaigns they can be effective. Again, of course, visiting the Capitol, visiting with legislators, calling when there's a bill up for a hearing. All these things add up. And the more we can do it, the more we have a chance to retake this conversation and drive it the way it should go.
By the way, we do have a mic. If anyone has a question, just raise your hand. Ray will bring you a microphone.
I have a question.
Yes.
Have you tried to organize the pediatricians of Texas?
We have.
What is the result?
So, the AAP has moved in a more pro-vaccine direction, but they still, and I understand why. If you're in a rural community, and it's hard to understand if you're living in Austin. Here in Austin, we have hundreds of pediatricians to choose from. But there are certainly lots of communities in rural Texas where you have one pediatrician that serves the entire community. So I can understand that there's an ethical issue with turning away families that don't vaccinate, right? That's the biggest question right now. Do you tell pediatricians that they have to turn away those families? I think in Austin, we've had a lot of examples of clinics and in private practitioners doing that. but again, I do feel for those that serve, communities that don't have a lot of choices. Medical access is an issue.
There's also the issue that if the pediatrician turns away the family for not being vaccinated, that certainly makes a very strong statement to that family, but it also makes it more likely that you will, in an urbanized area like Austin, that there will be certain pediatricians
Yes.
who are anti-vax, who
There
do
are
exist,
those.
unfortunately,
We
who
do
will
have
then
those.
become the gathering point for that group.
We have a few on our radar in Austin, for instance. They are the types of pediatricians that might ask you at your first visit if you want to go on a delayed schedule, for instance. That's a problem.
Yes.
Evidence shows the way that pediatricians approach the subject of vaccines very much influences the outcome.
This is apparently true across
Yes.
all vaccines for adults and kids.
Exactly.
As well.
And then you take even more controversial vaccines like the HPV vaccine, which prevents cancer, and we still have a lot of resistance, I think, from certain groups of pediatricians in terms of talking about it, being proactive about it. I think there are a lot of pediatricians that still say things like, well, it's up to you, I've even met certain, this wasn't a pediatrician, but another doctor who, she just told me she wasn't going to vaccinate her own children with HPV because of her culture. The problem is vaccines work, the science is there, the evidence is there, but in the end, we're all just humans, right? And humans can be,
Suck.
we'll say, victims of judgmental errors.
Yes.
Yes. So, I would, it's one of those things. I wish I could say that all the pediatricians were on board, but they're not. Most of them are. And I think a lot of what not my group does, but the Immunization Partnership does, is try to teach them best practices so that they can learn how to bring these conversations up with their patients in a way that increases our vaccination rates.
I've heard from various sources, and I've tried to apply this myself in conversations, that another, besides the doctor's recommendation, which is hugely influential, it turns out, that a doctor recommending a vaccine to somebody
Yes.
who's unsure,
Yes.
as you say, the hardcore folks you're never going to reach, but that
Yes.
the other thing that's tremendously influential is just people through other contexts, people whose kids go to the same school and you're having a casual conversation with them and the subject comes up.
Yes.
Is that something that you also promote with?
We absolutely promote that. Again, it's about starting that conversation, destigmatizing it. For whatever reason, I used to say this all the time. When I became a new parent, for some reason, parents are really opinionated. They'll talk about anything. They'll tell you if they're cloth diapering. They'll tell you if they're planning to breastfeed, if they're going to plan to extend breastfeed until the kid is 5. They will literally tell you anything. But for some reason, vaccines have always been treated as a taboo subject. And I had that experience myself. It's partly what motivated me to be involved with vaccine advocacy. I was in a parents group, and someone in the group did not vaccinate their child. And the admins got together and were talking about it. They asked me my opinion because they knew I was very pro-science and pro-vaccine. And I gave my opinion, and I ended up being admonished for being too judgmental. I should have tried to see it from her point of view or not be so mean to her, I guess. And then what happened is I left the group, and I found out like a year later, they were all at a mom's night out, and this particular parent came to that dinner with an active case of pertussis. And there were moms in the group that had
How
newborns at home.
unusual, by the way.
Yeah. Started out the dinner with a
Not-
slight cough, didn't say anything about it. About halfway through dinner, told everyone, well, I guess I should tell you, I do have whooping cough. And the moms were not happy. And she had all of the anti-vaccine myths in her head. She's like, I don't know what the big deal is. It's just like a common cold. You guys are all overreacting. So, this is the kind of thing that can happen in your real life. We're not talking about data. We're not talking about statistics. This is just one dinner with a bunch of moms. And that's what happens.
What we've learned is through this experience is that those sorts of personal stories are really what carries the message.
Absolutely.
Better than anything.
Yes. So
We did this vaccine TWiV a few months ago, Rich and I in Irvine, and one of the doctors on the panel said that the exemption rate nationally should be about 1%, because that's the true rate for real medical conditions,
Exactly,
right?
right.
But it happens to be up to 10% in some areas. Do you know what it is here in Texas?
So here, so in Texas, the hotspots are going to be Austin, the Fort Worth area, and then parts of Houston, not necessarily Houston, the urban center, because that's where Texas Medical Center is, but you get into some of the bedroom communities and you see some anti-vaccine activity. We are actually on a list that just came out. I think 3 of our cities made the top 24 vaccine exemption cities in the country. So it's not good. It's not good. And then again, the clustering that I referred to earlier. So Austin in general, if you look at it, has a fairly good-looking vaccination rate. But I know that, for instance, the private school that is 5 minutes from my house has an exemption rate of almost 50%.
Whoa.
So that's a problem, And they're not alone. If you're talking about Austin itself, there are some very popular areas of the city that, if you look at their individual school vaccine rates, they're not good. They're nearing 20% exemption rates. And that's actually a problem also, just to get to Texas-specific problems. So in Texas, when DISHES publishes the vaccine exemption rates for the state, it's only by the district level. So in Austin, that encompasses 130 schools. So that number really doesn't tell you very much. And I have members, they have children with leukemia, they have children with heart transplants. So they need to know, is that school I'm sending my child to going to be a safe place for him or her? And they can't get that information without filing what's called an open records request. And we've been doing this all over the state, wherever we can find a volunteer to file one. And it really varies the response. In Austin, it's been pretty good. We can get the information fairly quickly and they don't charge us. We've had certain school districts want to charge us up to $600 to get that information. So you're a parent and you're already struggling to go to your doctor's visits, get your kid taken care of and enroll them for kindergarten at the same time. And now they want to charge you $600 to find out if that school is a safe place to send your child.
And that's after you've filed special paperwork to get that information.
Exactly. Yeah. And then a lot of school districts don't even answer us.
Right.
They just don't respond.
So do you think there should be legislation to govern exemptions, and is there any future for that in Texas?
At the very least, we have to fight the onslaught of anti-vaccine bills that are coming. So 2017, we were able to get our what we call the Parents' Right to Know bill, which would make campus-level vaccine exemption rate data available publicly. We were able to get that out of hearing. We were not able to get it out of the House. But we're going to try again, hopefully. On the other side of things, the anti-vax side, they managed to get a bill heard that would have made it, if I remember correctly, it would have removed certain funding from pediatricians that turn away non-vaccinating families. So it would have taken away their CHIP funding and their Medicare, Medicaid, all that stuff. So we were able to fight that. If other states are any example, we are expecting this upcoming session in 2019 to be even more active, especially with the anti-vaccine activity. Oklahoma this past year had almost 20 or maybe even 20 or more anti-vaccine bills filed. So that is the situation. If you follow the news, New Jersey just had a huge fight that was publicized because they removed their religious exemption or made it tighter, and the anti-vaccine lobbyists there and supporters there, they got borderline violent at the hearing. There's footage of them screaming at the legislators.
We're from Jersey, by the way. So
yeah, you might want to look up that footage. But this is a fight that's happening everywhere. Colorado, they tried to declare autism an epidemic.
Of course.
It's happening all over. So we expect that this is not going to go away. So at the very least, if we can at least stop things in their tracks, that would be great. And then, of course, if we can move the ball more towards the pro-vaccine side, instituting some maybe educational requirements if you're going to opt out of vaccines, or requiring a consultation with your physician, something like that. I mean, the evidence always shows that the more barriers you put into place to an unwanted action, the less that unwanted action happens. So.
Yeah, the physician we had on the vaccine TWiV, he said his goal is to make it easier to be vaccinated than to get an exemption.
Right.
Yes.
And he actually wants to do it in schools.
And I would say in Texas, oh, I'm sorry, I actually got that wrong. now that you've said that. In Texas, I think our fight is we don't want to make an exemption easier to get than a vaccination. So the bill I described, I'm sorry, I misspoke. They did have a bill filed that would have removed that Medicare, Medicaid funding. The bill that was heard, however, was about making the vaccine exemption form more easily available. So currently, the way you do it, you file a request online with dishes. They fill out a form for you. It has a seal on it. It gets mailed to your house. You have to go get it signed and notarized, and you can bring that to the school. They wanted to have the seal removed. They wanted the form easily downloadable from the site, and they wanted forms required to be available in all school nurses' offices across the state, so that you could show up at kindergarten registration, and if you didn't have your vaccine records with you, just fill out that form.
I'm restraining myself from standing up and screaming. This is
my
really,
daily life.
Really.
Well, you are registered to vote in Texas. So.
Yeah.
It's true. Do you find the same people that are against vaccines are also against fluoridated water and pasteurized milk?
Or is
There's
it one
some
conspiracy per
overlap.
customer?
No.
Because if they're against science, then they're against all public health practice.
It really depends on the person. I think that, again, like I've mentioned, the group here, they are well coached. So they're not going to necessarily go into those areas. I think individual supporters might have that kind of thinking, but in terms of their public face, I mean, they have a very polished outer appearance. To them, they even claim they have people in their ranks that vaccinate. I haven't met any of them, because to them it's about choice,
Right.
freedom of choice. So they're not going to tell you that vaccines are bad, although if you bait them a little bit, it doesn't take very much.
They'll say some of their best friends are vaccinators, yes.
Exactly,
Right.
yes.
How about obeying the speed limit on the highway? I mean, there's a lot of things in life that you don't have a choice about because you do them for public safety. I mean, you obey the speed limits, you obey the stop signs, you obey the stop lights. That's not a freedom of choice. They said to do it, and you do it. So I
Well,
don't get this attitude about
we have a
I need to have the
legislator-
Because you're
freedom.
approaching this rationally, Dave.
We have a legislator
It is not
here.
part of
I'm
your
approaching
life.
it angrily.
Yes.
He
with Rich.
publicly said he does not believe that public health is a governmental issue. It's an individual responsibility.
Exactly. When fluorine in the water first came out, people were accusing the communists of trying to change our hearts and minds through chemicals. I'm not kidding. There were a group totally against fluoridation of water until their
secrets
kids
in
reached
Dr.
about
Strange
3
book,
years
but-
old and they had caries that had to be treated. Where did they come from? Well, you keep feeding them candy, that's what's going to happen.
Well,
It's a very sad situation. We're inventing a wheel again and again and again.
So, Jinny, how can people in Texas help your organization?
certainly, find our site, find our Facebook group, find our Facebook page. We'd
be
love to
linked in
have
the
you.
show.
That would be
I just like
wonderful.
you.
Thank you.
Good. I'm not on Facebook, but I would certainly.
Doing your homework. And then, like we've mentioned a number of times, start those conversations. You really don't know what people are thinking unless you talk to them. And it's not just people in your workplace or the parents. It's even your own family members. The number of people I've met who did not realize they had family members that weren't vaccinating and that had fallen down the rabbit hole of anti-science thinking is kind of shocking. But it happens. And we cannot sit by and just expect that the facts will protect us anymore. That is not the situation. And if you feel that way, I can't make you do anything, but I also am not going to be shy about calling you out if a measles epidemic happens. We all have a responsibility to advocate for science and to make sure that especially our legislators are not swayed by alternative facts or wooey thinking, vitamin C doesn't cure cancer. These are not things we want controlling the conversation when it comes to our public health policies, and certainly not in our communities.
So the site is immunizetx.com.
Correct. Yeah.
Jinny Suh, thank you so much
Thank
for
you.
joining
Thanks
us.
so much for having me.
By the way, you notice Alan and I wore the uniform.
Yeah.
Dixon apparently didn't get the email.
I don't have a blue shirt.
Rich, kind
is
of
just a
halfway.
rebel.
You got the pants, but not
Kathy
the
dresses better than any of us most of the time
So
anyway,
true.
so she's exempt.
Our next guest is from the Molecular Biosciences Department here at the University of Texas. Please welcome Jason McLellan.
This is my usual work attire.
Oh, okay. This is business casual?
Business
Okay,
casual.
good.
The academic uniform.
It's just casual, actually.
Nice sticker.
Thank you. Yeah, I found it on my seat.
Thanks for joining us.
Thank you for having me.
Jason, tell us a little bit about your history. Where are you from?
So I'm from Southeast Michigan.
Right.
Yep. I grew up just outside Detroit, and I attended Wayne State, which is in downtown Detroit. I lived there the last 2 years. Then I went to Johns Hopkins for my PhD, and then to the NIH for my postdoc. And then I started my lab at Dartmouth in 2013, and then moved here in January.
Wow.
Did you know Faye Right-Hand at Wayne State? She was a virologist. Yeah.
No, I didn't.
I'd like to tell the Faye Right-Hand story. She ordered a car once, and they put the steering wheel on the right-hand side.
Just because of her name.
Yes.
Her name.
Isn't that
Wow.
great?
Wow.
So how far back can you remember getting interested in science?
I think I've always been interested in science. I think the movie Outbreak with Dustin Hoffman was pretty influential. You know, they were able to cure Ebola in like a day or two.
Yeah.
How many marine biologists are there who were inspired by Jaws, right?
Right,
So,
exactly.
These things make
Yeah.
a difference.
Or dentists.
Or dentists. Yeah, so that made me realize, wow, vaccines are easy, right? We just need a monkey and some blood, and we have a vaccine.
You got it.
But it was really in college. I went to college for pre-med, and then ended up really having an affinity for chemistry, and particularly organic chemistry. So I sort of switched and became an organic chemist and worked in a synthetic chemistry lab for 3 years. And then I sort of found the literature a bit boring, just sort of synthesis of X and synthesis of Y. And I started taking some graduate level biochemistry courses and thought, wow, it's really the enzymes and pushing the electrons, and there's a lot more that's not known in the biology and perhaps in chemistry, and just kind of found that fascinating.
But you didn't go to medical school, I guess.
Right. Yeah, I did not go to medical school, so I decided protein biochemistry and like structural biology really spoke to me.
And so as a PhD, what did you do?
So as a PhD, I was in a structural biology lab in Dan Leahy's lab, who's over there in the audience. He's now the chair of the department. And so Dan's lab studied extracellular ligand receptor interactions, and I worked on the hedgehog signal transduction pathway. And so we determined structures of hedgehog and the mammalian homolog sonic hedgehog in complex with a new receptor family that Phil Beachy had identified. So I really love that, getting a look at the atomic coordinates and molecular positions and understanding the nature of the interactions. We found an unknown calcium binding site in sonic hedgehog that mediated the interaction. It could explain brachydactyly, a set of mutations that cause brachydactyly, sort of mapped to the acidic residues in the calcium binding site. And so that was sort of my first little taste of macromolecular structure in human health. And then for a postdoc, I really wanted to try and do something perhaps more applied, where we could try and generate things and take those insights and start to make products. And so I went to the Vaccine Research Center, which is a part of NIAID, and joined the laboratory of Peter Kwong, who's really doing a lot of pioneering work in structure-based vaccine design for HIV-1.
Former Columbia guy.
Former Columbia guy,
Yeah.
That's right.
He was with Wayne Huibregtse at Columbia.
As was Dan and Dan's wife and Larry Shapiro, and I know them well.
Do any
For
cryo-EM work?
members of the audience who were not versed in this, yes, Sonic Hedgehog is named after the video game character. This sort of silliness often happens with genes originally discovered in fruit flies because they're silly people who work on those.
Yes.
Just wanted to, if you were listening and that was the only thing you picked out and you were thinking, why are they talking about Sonic Hedgehog? That's the story.
Yes.
So does any of your work involve cryo-EM?
It does, and that's the primary reason I moved the lab from Dartmouth to UT Austin.
I thought they just ran out of Ben & Jerry's up there, that's all.
No, they will not run out of it.
No, I don't think so.
No, so I'm trained as a crystallographer, but since around maybe 2013, with the release of direct electron detectors, there's been this resolution revolution in cryo-EM, which has really been stunning. And so there's a number of advantages for cryo-EM. You don't need to grow crystals. You don't need to have those crystals diffract. So it's really opened up a lot of interesting questions and new avenues to pursue. You can look at some dynamics and look at different states. And so it was clear that this is an important tool that as a structural biologist we had to have access to. And so we're in no means giving up on X-ray crystallography because that can still answer certain questions in its own right. But we needed access to these new microscopes, and UT Austin just made a big investment of brand new facility, one of the Titan Krios microscopes, a Talos, a facility manager. They hired a young faculty member, David Taylor, either Jennifer Doudna and Ava Nogales' lab, and it seemed like a perfect environment to start learning cryo-EM and getting in on it. And so since we've been here, we've been just sort of getting the software pipeline down, working on some test proteins, achieved some resolutions less than 3 angstroms now, and so now starting to work on some real proteins that we have interest in.
Dixon, should we tell him we have a cryo-EM Nobel laureate at Columbia?
I don't think we have to tell him. We have to tell them.
Cryo-EM is a technique for using electron microscopy to solve protein structures, which only really became better than it had been very, very recently. There's been a revolution in this.
And cryo means it's frozen.
Yes.
And the advantage is that you don't have to produce crystals. For crystallographers, that was always one of the hardest hurdles to get over. And for cryo-EM, you don't have to do that.
And both of these are techniques to get the three-dimensional structure of a protein. So when you see news articles about scientists have solved the structure of some protein or viral component, and this is going to give us new insights, this guy, he's doing that sort of thing. So you moved from the north down to Texas to do this work on colder microscopes.
Yes.
Yes. Okay.
To try and
just clearing that up.
Offset the heat.
It offset the heat a little.
And the three-dimensional structure of a protein is just absolutely a beautiful thing.
That's the other reason you see a lot of news stories on them, because they're gorgeous pictures of these multicolored computer models. Of
What blows my mind is that you can isolate a protein or study a part of a virus for years and imagine what this thing might look like, okay? And then you get the real structure and you see what it really looks like, and you can see how it works. Amazing.
Yeah, it changes all of the drawings of triangles and circles into
Instead of
actual.
all looking like Pac-Man pieces.
Changes all the cartoon models.
It does.
So I have another question then related to that, and that is that every time we think we can't do something because of the resolution of something or because of the limitations of nature, someone finds a way to do it. Like Hyperloop, for instance. That's going to eliminate domestic air travel. I'm convinced of it. If it ever gets perfected, you can go from New York to Chicago at 750 miles an hour. That's faster than a jet airliner. You can get there in much shorter time. Okay, so in your field, what do you perceive over the next, tomorrow or the 20 years from now, what do you think the next breakthrough will be? In structural biology.
For structural biology?
Or what would you like it to be?
What I like it to be. Maybe more technological improvements, probably primarily for cryo-EM to better detector quantum efficiencies, increases in data collection time. So most data sets now would be in the 24 to 48 hour range. And so if you could get that down into the hours or minutes, that would be big. And that's sort of an advance we saw with X-ray crystallography. So when I started in 2002, 2003, some of the data sets at these synchrotron facilities could still take hours. And now it's a matter of minutes, essentially. And so that just provides a lot more access to it. You can start to answer new questions like time resolve changes and other things like that. I think improvements in the software and the processing capabilities. I think there'll be a lot of advancements in tomography, which is where instead of looking at many single individual particles and averaging them together, you just collect on one virus. And so there, the resolutions are perhaps more limited, but I think in that way, with new advances, we'll start to see increases there. We can start looking at maybe the fusion of a virus into a cell and things like that.
Do you think you'll ever be able to see the actual event happen? A chemical reaction from start to finish?
It's frozen.
No, I didn't say using cryo-EM. I said, do you think you could ever be able to do that, regardless of that? Isn't that what you'd like to do?
That's what you'd love to do, is look at the individual molecules.
Of course. Because I saw something on atomic force microscopy in Science recently where they actually observed the benzene ring that Kekula had dreamed about. And here it was, right in front of you. It was a hexagon. It looked like it was fantastic. That's the way it does look.
Dixon's question speaks to, I think, the issue in a lot of your work about fusion, right? Because the fusion proteins on viruses that fuse the envelope with cellular membranes. That's a very dynamic process, right? And you try and understand that dynamism by getting individual structures before and after. Right?
Yeah, and for most viral fusion proteins, what we have is the initial state and the final state. But we don't know that much about the refolding pathway between them. But we have some molecular dynamic simulations and some trajectories and things, but capturing intermediates is very tricky, and whether they're biologically relevant intermediates is sort of another question as well.
It's like that cartoon with the formulas on the board, and then a miracle happens, and then
and
more
then, yeah, and then the post-fusion form,
right.
and the virus enters.
So you can try to trap intermediates in various ways. Right?
You can, but the trapping itself could then be an artifact of the trap. And
So one way would be to have a mutant, an altered protein, right, that freezes at a certain point, but then your argument is the same. Right?
Yeah, the reviewers would note that.
Or a chemical that might trap it, but then they would say
Then they
it's
would
a
say it was
chemical.
chemical, right?
So then how do you do it? How would you solve Dixon's problem in a frozen state?
You have approximately 4 minutes.
I mean, one way that we've been successful with trapping proteins is using monoclonal antibodies. And these are antibodies that we often, or our colleagues, isolate from humans from natural infection. And so in that sense, then what you're looking at, antibodies have been raised against antigens naturally, and that the antigens have sampled some conformations, at least in the people, that were sufficiently long-lived to raise an antibody against. And so I think that helps. And if you can get a number of antibodies and they start to recognize different conformations, you can start to get some idea of the flexibility in movement that can undergo. But yeah, otherwise, you'd really want to start looking somehow at the individual molecule level of fusion in action as a pore is forming. But
So the essence of your research is just looking really, really closely at things.
I would say that's only one part of our research. I'm primarily trained as a structural biologist,
right?
But
just looking really, really closely at things.
Actually, we've published some of the lowest resolution X-ray crystal structures, to date, I think.
Just looking closely with your glasses.
Yeah. Because you don't need. It depends on what your question is,
right.
And not all questions require atomic level information, and so we try and get the appropriate level of resolution needed to answer our question.
And there's a trade-off between resolution and other types of information that you might be trying to get about the system, or the speed at which you get that information, or the size of the...
I think that's correct. Ultimately, what we're most interested in doing is using that structural information and then trying to design a vaccine or a small molecule, or create a probe to isolate an antibody, and do it in this rational, structure-based manner.
Now you've had... go ahead, Kathy.
This is This Week in Virology. So I'd really like you to talk about the virus that you're interested in with respect to all of this structural biology.
Structural biology. Yeah.
No, I mean, because I think you have a really cool story about that. So
So the virus that's maybe the major focus of our research is respiratory syncytial virus. And so this is a virus I started working on while in Peter Kwong's lab. And so while the main focus is trying to get an HIV-1 vaccine and apply all these new methods of structure-based design to do that, the problem is that you generally fail when trying to create an HIV-1 vaccine. Yeah. And you don't know whether that's because it's an almost perfect virus or because the structure-based design concepts aren't good. And so the idea was to try and apply it to more tractable virus, a virus that's glycoprotein is perhaps less antigenically variable, didn't have as much sequence variation, et cetera. And so Barney Graham, who was working on the second floor of the VRC, is a world expert in RSV, and he said RSV is a perfect virus to try and do structure-based vaccine design. And so we started and we did something called epitope scaffold transplantation, where we tried to remove neutralizing epitopes from the RSV fusion glycoprotein and transfer it into a heterologous acceptor scaffold, and then use that as an immunogen to re-elicit target antibodies. That was in collaboration with Bill Schief, who's now at the Scripps Research Institute. We then determine the structures of the post-fusion conformation of the RSV F glycoprotein. And then we use that to isolate pre-fusion specific monoclonal antibodies that were neutralizing and could recognize the pre-fusion form, which is somewhat unstable. And so with that, we could trap the pre-fusion conformation bound by an antibody and determine its structure. Using that structural information, we could then design in mutations to lock the F glycoprotein in its pre-fusion state in the absence of an antibody and use that as an immunogen. And so I was able to identify 2 serine residues that were hydrogen bonding to each other, one in a region that moves between the pre and post-fusion state, and one in a region that stays the same. And by changing those to cysteines, it formed a disulfide bond. So that locked most of it. Then we introduced cavity-filling mutations. So normally you're taught that proteins don't have a lot of voids and cavities and they're densely packed. But for a viral glycoprotein that has to undergo a huge conformational change, you have to build in some sort of flexibility. And so we identified some pockets and we could replace a serine with phenylalanine and it fit. And then that really helped lock the protein down in the pre-fusion conformation. And then our Barney and colleagues immunized mice and macaques. The neutralizing antibody titers were the highest we'd ever seen for a vaccine antigen. And so this was a runner-up for Breakthrough of the Year in Science in 2013, sort of proof of principle for structure-based vaccine design. It's the protein that we created, we have a lot of IP on it. It's now in phase 1 clinical trials at NIAID, and the results that we're seeing in humans look exactly like what we saw in mice and macaques. So that's really exciting. There's a lot of interest from other companies. Pfizer has their own molecule, I think I can say, that is similar. Yeah, they have a patent, right? Okay. So it's kind of a race now for looking at the pre-fusion molecule. And now we're trying to apply these concepts to other viruses that have class 1 fusion glycoproteins, such as coronaviruses, which we've been able to stabilize the spike glycoprotein, metapneumovirus, which is a close homologue of respiratory syncytial virus, starting to try and make structure-based chimeras where we can swap neutralizing epitopes between the F proteins of RSV and metapneumovirus to sort of make a chimeric where one molecule can elicit antibodies against both RSV and metapneumovirus. So all really informed and guided by structure.
So the idea, a lot of structure-based design programs, you take the structure of the molecule and then you go to your chemists and you say, build me a small molecule that I can turn into a drug that'll fit into this space. What you're doing is saying, how do we train the immune system to make an antibody that will fit here and lock up this virus? And
so the idea is that you're generally inspired or guided by the isolation of monoclonal antibodies that have desirable properties. Right? There's been technological advances in antibody isolation, right? With single B-cell sorting and being able to isolate antibodies from sera and determine sequence, something that George Georgiou and others do here. So with this, we can now look at hundreds or thousands of antibodies and identify those that are the most potent or the most broad, and then determine which antigen can recognize it and how, and then design an antigen to re-elicit those groups of target antibodies. So it's a really, really rational approach to that. And so we work with a lot of companies. We've published papers with MedImmune and Janssen and Merck, and we're in discussions with others. And so it's really kind of taken off, and it's an exciting time. We're even branching into bacteria a little bit, which I know.
So here we have a dichotomy of sorts. We have incredible technology. Someday we'll have really good vaccines, and on the other hand, I wouldn't say no one, but there will be a fraction of people that will not take advantage of this, and especially for respiratory syncytial virus, which, as you know, is incredibly important at a very young age. Alan and I just did a TWiV at Halifax where we heard about a study done in 5 different countries at the major cause of childhood pneumonia. The top candidate was RSV, yeah. And they were surprised, totally surprised.
Really?
Not.
Well, yeah. No, because the pneumococcal vaccine has knocked that down. So now
somebody else rose to
you hit the number 1.
That's right.
And now you've got the next,
That's right.
the world's next top virus. It comes into the fore, and you look and you find RSV is this huge cause of pneumonia globally. And it was actually a really interesting, incredibly massive undertaking that you can go back and listen to that TWiV to hear more about.
There's Kate O'Brien, who's from Bloomberg Johns Hopkins. It was done under a Gates Foundation grant. It took 6 years, $40 million.
Yes.
And all they did was sample children with pneumonia in 5 different locations.
All they did, yes. And coordinating all of this and figuring out how to do it in a way that would give you good data.
You should listen to it.
Yeah,
it's
great
really
idea.
interesting. But I wanted to ask you something about, we did a paper of yours on another one of our podcasts, immune.
Yes.
I have a thing, I'm not an immunologist, but I can understand.
I'm not much of one either.
I can understand when you want to look at antibodies binding to viruses. So this is part of my arc. And we did your very cool paper about RS, respiratory syncytial virus, neutralizing antibodies from humans. They're potent, broadly reactive, and they lack somatic hypermutation. They're encoded in the germline. Have you thought about that and what it means?
We did, because we published a paper on it.
It's good that you've thought about it.
Yeah, so I considered it. No, it's pretty fascinating. We were really surprised to see that. It was only when we looked in infants that we could see this, and they were directed against one particular site on the virus that we now have structures of, so we can understand why and how a germline encoded antibody can recognize that. It's interesting, and so. We have many different V genes that are encoded in our genome, but they're not random, and they've been selected for in some way. And so,
you think that RS has selected for these in humans?
I don't know. Possibly
that's an idea, right?
Possibly it's an idea that there is, some innate antiviral response that. There are different antibody V genes. The VH169 is commonly found against viruses. It has a hydrophobic CDRH2 loop. It binds to the stem region of influenza HA, and you see it pop up over and over. So perhaps there are some V genes that have been selected for, especially for RSV, which infects nearly all children by the age of 2.
Well, that's what the idea is, that maybe it's been applying pressure on humans for many, many thousands of years. Whereas, as you point out in the paper, there are no germline encoded antibodies against HIV-1.
Because it's new.
It's new.
Yes.
It hasn't had time to put the pressure on, so to speak. Tell us what your structural contribution to that paper was.
Yeah, so there was, we worked with Laura Walker in a company called Adimab LLC, which does fantastic work. And so we used our pre and post fusion molecules stabilized. And this was work done by one of my graduate students, Morgan Gilman, who's in attendance, as well as Daniel Rapp, who's coming back from a trip. And so we came up with ways of putting a single biotin molecule per trimer and then making those tetrameric for use of sorting single B cells. And then from the single B cells, we could isolate hundreds of monoclonal antibodies. And then we saw that there were certain properties. There was a number of antibodies that recognized what we called antigenic site 1. This is a site that the antibodies that recognize it tend to be non-neutralizing, are quite poor. And they had certain properties. And we also found these other ones that were completely somatic that all used the same heavy and light V gene. And they recognized antigenic site 3. And so our structural contribution was to determine X-ray crystal structures of each of these antibodies in complex with the F-glycoprotein and explain why those V genes have been selected and how are they binding.
Does it explain why they're so potently neutralizing against that particular site?
We have some ideas. In general, the neutralization potency correlates fairly well with affinity. So these all bind with high affinity. And the most potent ones tend to bind regions that need to undergo a conformational change between the pre and post-fusion conformation. So they're binding and stapling or locking it into pre-fusion conformation. Some of the most potent tend to be those on the upper hemisphere of the molecule, which on a densely coated viral surface would be sort of most exposed to antibodies.
So does this inform vaccine development at all?
Possibly. For that paper and the previous paper where we isolated 300 monoclonal antibodies from adults, we saw that the most potent antibodies are again against the upper hemisphere, which is specific to the pre-fusion molecule. And it suggests that you would want to have those epitopes in a vaccine. You'd want to use pre-fusion F in a vaccine. In terms of something maybe more specific, it would be interesting if we could try and make some sort of antigen or epitope scaffold that specifically elicited those germline genes, those germline antibodies for use in an infant, right? So most vaccines, there's a single vaccine for everybody. But as we start to get more information, we realize that something like RSV, where you have vaccine target populations of infants and neonates, pregnant women, and elderly, those are different immune systems and could benefit from having different antigens, different delivery modalities, et cetera. And so it would be really interesting to take it to the next level of age-specific vaccines.
Actually, Kate O'Brien suggested immunizing mothers who would then passively transfer it to infants, and then when they're 10 months of age, and you could give them a different vaccine.
Oh yeah, that's a major focus and Gates Foundation through PATH is putting a lot of money behind the maternal immunization route, I think due to successes of a Tdap vaccine.
All right, before we let you go, tell us what's hot right now in the lab that you're really excited about.
I mostly can't. There's quite a few things that are interesting, but a lot of it's confidential. So.
It's the first person ever on TWiV to say no.
We're really excited about the cryo-EM efforts, and so it's kind of neat. 15 years after starting graduate school to learn a whole new field in structural biology, sort of work in real space and see individual molecules. So we're really excited by a lot of things there and a lot of our excellent collaboration.
Can you say which virus? I guess not.
He has to make a phone call first.
Yeah.
Is it a negative stranded RNA virus?
Positive strand. We're actually pretty excited by a lot of the stuff we're doing in coronavirus, and we think that it's a ripe time now to start trying to do what has been done for HIV and flu and identify broadly protective coronavirus antibodies and vaccines that could work against MERS and SARS and many, something you could hoard before the next coronavirus emerges and have something already in hand.
By the way, you follow the influenza field and their efforts to make broadly neutralizing vaccines. How do you think that's going?
I think there's a lot of good people doing a lot of excellent work. There's a lot of money in the universal flu vaccine. That has a challenge that RSV doesn't, due to the antigenic drift and shift. And so, a lot of the ideas, whether it's focused on STEM or STEM nanoparticles or prime boost regimens, there's a lot of things that might work in a lab, but then getting it in practice to work in a population is difficult. So there are some strategies that require 3 or 4, a prime and then boost with heterologous proteins, and it's difficult to get people to come back for even a boost sometimes, or even
for people to get one
shot. Exactly,
yes.
and so
Or at all.
or at all,
any shot,
Yeah, this has come up before that the best vaccine, which probably would get the most acceptance, would be a single microneedle patch for everything once, and that's it. Yeah. And then maybe you'd get even more uptake. And no needles, right? But
some of these strategies where it's a prime, boost, it's hard. It's hard.
I know. Well, Jason McClellan, good luck. Nice having you, and thank you for joining us.
Oh, yeah.
Our final guest, don't leave. We're going to have a contest at the end.
Yes.
Well, you have to go and
You can win
let it
valuable
go.
prizes.
Sure, we're
prizes
serving
anyway.
pizza.
Final guest is also from Molecular Biosciences here at the University of Texas. Please welcome Jon Huibregtse.
Thank you. Great to be here.
Did I get the name right?
Pretty close. Pretty close.
That was a no, Vince.
I know.
It's okay, I get the same thing.
Yeah.
How do you say?
That's for every class I teach. That's slide 1 of lecture 1. Phonetic pronunciation.
So tell us the
Well, it's arbitrary. It's a Dutch name. We say Huibregtse, but that's certainly
Huibregtse.
Huibregtse.
Okay, I said who, so Huibregtse. Huibregtse, sorry. Please welcome Jon Huibregtse.
Yeah.
So, Jon, tell
Fix it
us.
in post.
Yeah, he just wanted more applause.
Why not? Tell us a little bit of your history, where you're from and educated and so forth.
Believe it or not, southeastern Michigan.
Really?
We didn't do that deliberately.
About halfway between Ann Arbor and Detroit. So high school, you could enjoy the wonders of late 70s Ann Arbor and still get a job at an auto factory in downtown Detroit in the summer. That's about the last time you could ever do that. Right. Yeah. And so I went to the University of Michigan. both for undergraduate and graduate work. I did my PhD with Dave Engelke.
Yes, and I knew him from my California days. I knew him back actually when he was at UCSD and at Caltech.
Interesting. So that was not virology. I was studying RNA polymerase III transcription complexes in yeast, actually. Developing some genomic footprinting approaches for looking at structures in intact cells.
You're supposed to say you took advantage of the awesome power of yeast.
Yes, I forgot to say that.
That was
Actually, we didn't. It was mostly.
Okay, great.
that was a PhD, right?
That was PhD.
And what did you do as a postdoc?
Postdoc, that is where it took a turn towards virology. I went to National Cancer Institute in Bethesda, Maryland, and I was worked with Peter Howley on human papillomaviruses, and which are, of course, associated with cervical cancer. And that lab made important contributions to understanding what the two oncoproteins that are expressed by HPVs, what they are actually doing at the biochemical level, how they are functioning as oncoproteins. And that was an exciting time, late 80s, early 90s, in trying to figure out what those proteins did. And that is what led us into the field of ubiquitin-mediated proteolysis, because it turns out that the E6 protein of the high risk, the so-called high risk HPVs, the cancer-associated HPVs, the E6 protein is hijacking a ubiquitin ligase and causing it to target P53, the world's most famous tumor suppressor for ubiquitin-mediated degradation. And so that was, from the cancer perspective, that was very important, but it also led to the molecular cloning of the very first ubiquitin ligase ever to be seen in the flesh. And
I think there's going to be a lot of ubiquitin in this conversation.
Yeah.
So could you give us a
Before you do that,
sure.
Hold on. Before you can.
Okay.
And then you came here from your postdoc?
Well, actually, my postdoc was split. Peter Howley moved halfway through my postdoc up to Harvard Medical School to be chair of the Department of Pathology at the time. So I was split between those two places. A fabulous experience being at Harvard Medical School and being around the whole, interacting with, for example, the Weinberg and David Livingston and Ed Harlow labs, in an exciting time in terms of figuring out how RB, P53 were functioning. And then from there, Bob Krug hired me at Rutgers. So I was there for 5 years as an assistant professor. And he preceded me to Austin by a year. He asked me to come and take a look at it. And so in 2000, I did that, and we really liked what we saw here, and so we've been here since 2000.
And one more thing before you get into the ubiquitin.
Yeah.
Can you remember how far back you got interested in science? What was the catalyst, maybe?
Oh man, I always was. I can't say there was a single catalyst, but I think my friends saw it in me before I realized it, and they would always. Yeah, just kind of assumed that that's where I would go. So I can't say there was a single thing, but I was always terribly interested in
Inborn error of metabolism.
Yeah.
All right, go ahead, Rich.
Right. So
ubiquitin.
Ubiquitin. Give us the primer on ubiquitin.
So ubiquitin is present in all eukaryotic cells, all animal cells.
Hence the name.
Hence the name. And it looks like, if you take your hand and do the classic hitchhiking pose there, that's what ubiquitin looks like, a small globular protein, and with the thumb sticking up there, and that thumb is the C-terminus of ubiquitin. And that's where most of the biochemistry comes into play there, where that C-terminus of ubiquitin is really attached to other proteins in the cell. And the most well-characterized, what most people understand, is that putting that ubiquitin onto other proteins serves as a tag for the degradation, for the destruction of that protein to which it was attached. Right? And it can have all kinds of other functions as well, but that's how it was first characterized, as a destruction mechanism. And for proteins, how to get rid of proteins within cells. We know how to induce genes to make new proteins, but it's just as equally important to get rid of the proteins that you made yesterday or an hour ago or when they get damaged, right? And that's what ubiquitin does. And it's now recognized, Nobel Prizes have been given for it, and it's recognized to influence virtually every biochemical pathway.
And so in your work with Peter Howley, the fundamental discovery was that this human papillomavirus gene, human papillomavirus being a virus that can cause tumors, right? Causes assists in ubiquitination of P53. So play that out strategically. How does that help the virus?
Yeah. So E6 is hijacking one specific ligase and essentially changing the substrate specificity of that ligase. In other words, that ligase that puts ubiquitin onto proteins didn't evolve to do it to P53. It's E6 taking it from its normal job, causing it to target P53. And P53 is normally mutated in a huge number of cancers, of course. And so, except for cervical cancers, because the P53 protein is being gotten rid of through this destruction mechanism. So that's one case where you don't see selection for P53 mutation.
P53 ordinarily...
So P53 ordinarily helps to suppress or control growth of cells. So getting rid of that negative growth regulation is essentially promoting the unrestricted proliferation of that, of those cells.
I remember when those papers came out. We discussed them in a journal. You know, I don't remember many papers that we discussed in Journal Club when I was at UF, but those were some of them because it's just amazing work. I love not only that, but you did all this. The work was in a rabbit reticulocyte system, right? And I thought, when I first saw the results, I looked at that and I thought, you know, if I'd have gotten those preliminary results, I just would have said something's wrong and thrown it out. Yeah, right. That would have been the end of it.
Yeah. So Martin Scheffner was a postdoc with me in Peter's lab, and he and I started at the same time, and it was just such a wonderful scientific experience to work out that pathway. And it does, to your point though, you know, when we joined the lab, Martin and I, it had just recently been shown by another postdoc that E6 could bind to P53, and people thought that was the whole story. And you know, you're always taught as a good biochemist to do your experiments in the cold room, right, or on ice, right? So he had mixed the former postdoc had mixed E6 with P53 and done a co-immunoprecipitation. Yeah, it binds, and that was all fine and good. But Martin did the key experiment where he just mixed them together at room temperature and in reticulocyte. And the thing is, all those ubiquitination reactions were being suppressed by the cold temperature on ice. You raise it up to room temperature, the ubiquitination happened, the P53 disappeared, and that was the start of it all, right? Figuring that.
And I would have said, you know, the P53 got degraded, something's wrong, and, you know. Exactly. But that was what was right.
Something was wrong, you got cancer.
How many times does a mistake lead to something, right? We hear that over and over again.
You remember Pasteur's expression on that one, right?
What's that?
Luck favors the prepared mind.
Are you sure he said that?
I was there. Okay?
Dixon, didn't he say it in French?
Yeah, so the last thing I'll say about that story was that, you know, E6 is hijacking this ligase to do something that's not normally supposed to do, which is target P53. So you ask, well, why does this ligase exist to begin with? And it turns out that it's in all cells of the body that we've ever been able to detect, but it plays a key role in the brain and is the disease gene in a neurologic disease called Angelman syndrome. And it also plays a role in autism as well.
Well, what's the natural substrate of this ligase? It's not P53.
Exactly. That is what we have been, and many other labs been asking for 20 years, and nobody can still give you an explanation. The amazing thing there is that the gene for E6AP is on a really odd place on chromosome 15, which involves a lot of genomic imprinting. And what's happening there is that on in all cells of your body, both alleles of E6AP are expressed, except when you get to the hippocampal neurons and Purkinje cells, only the maternal copy is expressed. The paternal copy is shut down. So what happens in these Angelman syndrome patients is they've acquired a mutation on the maternal copy. So now they're essentially null for E6AP, but only in those neurons. And that leads to these amazing phenotypes in these Angelman syndrome.
Are you still trying to find the?
Yes, we are.
Now you have a way of doing this, right?
Yeah, we came up with a odd approach for trying to identify substrates of ubiquitin ligases, but it's also an approach that can be used to identify interacting proteins of virtually any protein.
And Dixon would like to hear the name of that.
It's
I would
called
love to hear this.
UBAIT.
See, fishing.
UBAIT.
Yeah, I do like that,
Heard of
actually.
that? So this is it's a really incredibly simple thing where, so again, ubiquitin is a very small protein, and people for years have been making tagged versions of ubiquitin, put a small flag or HA epitope on the N-terminus so you can detect it. Okay, so that small epitope doesn't hurt ubiquitin. And we just decided what would happen if you put a really large tag, that is your favorite protein that you're trying to study, okay? So, in other words, if that small tag doesn't interfere with the biochemistry of ubiquitination, maybe the big tag doesn't even interfere, and that's pretty much what we found, okay? So imagine your favorite protein with ubiquitin at the C-terminus, and because it's at the C-terminus, that thumb is still available for all the chemistry, right? So, what we found is that protein could still go through the first steps of the ubiquitination pathway, which would essentially chemically activate the ubiquitin that's now at the C-terminus of your protein. So what the point of this is that if your protein of interest is interacting non-covalently with some partner protein, adjacent to a chemically activated ubiquitin, a lysine residue of that interacting protein may react just by proximity with that ubiquitin. You will have covalently attached your favorite protein to its interacting protein. So that's one of the ways that we're trying to...
It's a way of finding what would be really tough to detect binding interactions.
Yes, right. Really a way of covalently trapping
Freeze
transient
those,
on-off.
So your protein is the bait and ubiquitin is the hook, and you're going to covalently bind these, and then you can find them together.
But I throw all my fish back, so I don't know what you're going to do here.
Well, and you don't use bait either. You're a fly fisherman.
That's okay. It's a marvelous story, though.
And then the identifications and obviously based just on protein mass spec.
So using this UBAIT, you have not been able to find the
Exactly right. So my feeling at this point with E6AP, the ligase that we originally identified in HPV scenarios, I start to think that it's involved in general protein quality control of some sort. In other words, it may not have a specific target. It may be, again, ubiquitin is ubiquitous in terms of its functions. And we understand a lot of things that happen with respect to cell cycle regulation, very specific proteins being degraded at very specific times, but that's only part of the ubiquitin system. The other half is this just overall protein quality control and turnover. We actually know very little about that side of the equation. We know a lot more about this interesting cell cycle kind of things going on. And so I wonder if E6AP is over there on the general protein quality, health of the cell kind of thing. And we discovered it because E6 took that general ligase and said, come with me, let's do something really specific, that is target P53 in the context of an HPV infection.
So let's segue to ISG 15.
Yeah.
So last time we were here, TWiV 255, October 2013, we had Bob Krug on. He talked about ISG 15.
Yeah.
And you've been working on it. So first of all, tell us what it is again, because we don't remember Bob Krug's episode.
Yeah, well, I'll try to be very careful what I say there. But so it turns out that, so I said ubiquitin looks like a hitchhiking pose. ISG15 is a ubiquitin-like protein that kind of looks like two of those stuck together. So it's double the size of ubiquitin. And the interesting thing, which gets us to the innate immune response, is that ISG15 is only expressed in response to type 1 interferon stimulation. Okay? So it's one of the hundreds of genes that are turned on in response to
Virus.
to viruses, right? And in fact, we became interested in this because of Bob's work on flu B, where he reported that the NS1 protein, among the many things that it does, one of them was to block the conjugation of ISG15. So ISG15 had been around for years, not really been studied very, very closely, but Bob's finding, the fact that NS1B was interfering with ISG15, kind of was the first circumstantial evidence that this, other than the fact that it was interferon stimulated, that it was probably playing a role in antiviral responses. The fact that flu had gone out of its way to interfere with the function of this ubiquitin-like protein was a pretty compelling piece of information. We looked at it, it came to us, we looked at it and said, geez, nobody knows anything about this. So we began to characterize the way, the enzymes that were required for attaching ISG15 to other proteins, and ultimately try to address the question of what ISG15 is doing to those proteins to which it's attached in interferon-stimulated cells.
So the attachment of ISG15 to the protein by ubiquitin ligases?
Well, by ISG15 ligases.
Okay.
So it turns out there's one specific ligase for ISG15. So for ubiquitin, there's hundreds of ligases that all have, the idea is they all have their specific substrates. For ISG15, there's one ligase, which was surprising because we could tell from proteomics that there was hundreds, if not thousands, of different substrates. So the question became, how does this one ligase, how is it able to put ISG15 onto so many proteins? And the short answer to that is that the ligase for ISG15, called HERC5, is sitting on the large subunit of the ribosome. And it's basically stochastically isogylating, putting ubiquitin onto protein, anything that's being translated in the cell. Okay?
So it's going to see every protein that gets made.
Pretty much. Now it does so inefficiently, so if you look at the pool of any given newly synthesized protein, it's a relatively low level, like maybe 5 or 10% of the total any newly translated protein will be isolated. So then the question is, what is it doing to those proteins? And so we said ubiquitin is a degradation signal. ISG15 is not. Okay, it has nothing to do with protein degradation. Okay? And the model we came up with, which has been tested in a couple ways, is that we start to think that ISG15 is basically a molecular blob.
A molecular
blob. It's not, just going onto proteins is a way of disrupting their function. And so let's go back to interferon stimulated cells. Imagine you have a cell infected by a virus, which is going to respond to that by making interferon, type 1 interferons, which are small molecules, proteins that will be secreted from the cell, and they will go stimulate the interferon receptor on adjacent cells. And we believe that ISG15 is mostly important in that secondary cell. And so you get the expression of ISG15, all of its conjugation components going in that cell, okay? So now when this first cell makes progeny virus, which then go attempt to infect that next cell, they of course have to use the host cell ribosomes to make their own viral proteins. So they're hitting everything, but we believe that the biologically relevant proteins are the viral proteins.
So it globulates all of
it globulates everything that's been translated. But we're still left with this issue of it does so inefficiently. So what good is globulating 5% of a viral protein, right? So what we came up with is that perhaps what's happening here is that if you think about a lot of viruses, the most abundant viral proteins are going to be proteins that oligomerize, like capsid proteins. So if you think about trying to disrupt the function or the assembly or the infectivity of viruses,
you don't have to disrupt every capsid protein.
Exactly.
Just have to get one,
Right.
two.
So we
One
think
out of 100.
Right. So it could be dominant negative with respect to its inhibition, right? And that would make some sense because if it was very efficient, you would expect it to be extremely cytotoxic, right? Because it can't distinguish between a viral protein and a normal cellular protein. It's putting this onto everything. right? So we think it's tuned to be inefficient, so it can be antiviral, but not so efficient that it would be toxic to the cell.
So it's damaging proteins in a way that hits particularly hard on viruses because viruses have this fairly unique trait of using highly oligomerized proteins in their capsids, and that's a universal trait of viruses, is that you're going to have some highly oligomerized thing to make a capsid.
And so we showed that with the human papillomavirus pseudovirus system, going back to our HPV days. And then Bob Krug's lab finally came around to kind of believe in this model, and he, in fact, showed that this mechanism applies to inactivation of the flu B nucleocapsid protein, which oligomerizes around the viral.
Right.
So do they just accumulate in the cell, or do they then become ubiquitinated and then processed?
Good question. Good question. We so far don't see any evidence that it affects, in general, the half-lives of any of the proteins that...
It just sequesters them and keeps them out of harm's way.
And very interestingly, a lot of viruses have evolved to encode deconjugating enzymes. So ubiquitin can go on
would have to.
Yeah. to reverse this, right?
So, John.
Oh, wait, I have one question.
Yes.
ISG15 has another function, right?
What I was going to say.
Yeah, it has probably two other functions. And the second function that we've been looking at most closely came out of the blue for us. So ISG15 had been around for like 25 years. Nobody was studying it. But some of the first papers that were ever published on ISG15 said that it was a secreted cytokine that elicited interferon gamma responses, a different kind of interferon, right? And those were old papers.
Did we ever say that ISG stands for?
Interferon stimulated gene. Yeah. The 15 comes from the molecular weight of the protein, 15 kilodaltons, which is about twice what ubiquitin is.
Okay. Cell biologists are a lot less creative than fly biologists.
Yeah. So we had these 25-year-old papers or so that said that ISG15 was a secreted cytokine, and we thought about that. We knew about those papers, but you go back 25 years ago, people didn't know much about the ubiquitin system, so it was like, So I have to say, we had largely discarded those papers from further thought. And then we were contacted a couple years ago, over 5 years ago now, by the lab of Jean-Laurent Casanova at Rockefeller University, who's been studying for years this disease called MSMD, Mendelian Susceptibility to Mycobacterial Disease. So non-viral, this is a microbial origin, etiology. And what this is, what they're looking for is for kids who are given a vaccine. This is not going to, maybe shouldn't go into this too deeply, but this is not a good vaccine. This is actually not a good vaccine, not a very effective vaccine. And it's only given in parts of the world where TB is a very big problem.
This is BCG, right?
Yes, this is the BCG vaccine, which is a live attenuated microbe.
The Bacillus of Calumet and Guerin.
Yes, right?
So
it's not my understanding is it's not a terribly effective vaccine, okay? But again, it's live attenuated. And you give it to most people, they get some protection, but they don't get sick. They don't develop mycobacterial disease from the vaccine. However, if you go to the places of the world where this vaccine is actually used, and in the case that's relevant here is in Turkey and Iran, you go to these isolated villages, and the rates of consanguineous marriages can approach 60%, right? So this is fertile ground for identifying recessive mutations that lead to genetic susceptibilities. And so this is, for example, a place where you might expect this vaccine to be given. In Casanova's lab, for many years, have identified kids who develop mycobacterial disease as a result of receiving the vaccine, all right? And then they have done amazing work in mapping the genes that are essentially mutated in these kids who develop mycobacterial disease. And they had done this like 6-7 times, and everything that they identified, every gene was in the interferon gamma response pathway, either making interferon gamma or responding to it, okay? IL-12 receptor, interferon gamma receptor, you name it. Everything was in the pathway consistent with what's known about how this microbe is dealt with. And they contacted us because they identified 2 new families, one in Turkey, one in Iran, and lo and behold, they were homozygous mutant in the ISG15 gene. And they had this susceptibility. They developed mycobacterial disease in response to the vaccine. And they said, they called us up and said, what do we think? We said, because to them, they have PubMed, right? They looked at it, they found immediately the 25-year-old papers and said, aha, just another gene product in right? And we said, hang on, you don't actually believe those 25-year-old papers. But it was all true that ISG15, getting to the second function, really does appear to be a secreted protein that induces interferon gamma responses. So totally separate from this intracellular ubiquitin-like function that we expected. And so our recent work is the idea was then, okay, it's secreted, is there an actual receptor for ISG15 on the cell surface of which cells? We wanted to know that as well. And it appears, well, it's for sure that natural killer cells are the primary cells that are responding to ISG15. So we actually use this UBAIT approach to make a UBAIT to ISG15. This is Caleb Swaim's work, who's in the audience here. He made a UBAIT with ISG15 to identify the receptors. So in other words, we made recombinant purified ISG15, fused to ubiquitin, charged that up with the E1 and E2 enzymes and ATP, threw that against natural killer cells, and covalently linked it to the receptor, which we pulled out and identified by mass spec. And the receptor is LFA1, which is a integrin, alpha L beta 2 integrin, which is an important receptor in both T cell and NK cell biology.
And it's a ligand for ICAM1, right?
Yes, a ligand
which
for ICAM1.
is the receptor for rhinoviruses. So you think about that.
Yeah.
Maybe it means something with ISG15.
Possibly.
And is that the only function of ISG15? I bet
The only
not.
2 functions?
There is yet another one, a third function. It's really quite amazing. So going back to the fact that ISG15, like ubiquitin, can be removed, and so certain viruses make de-isolating enzymes. There is a normal human protein that de-isolates. Okay, it's called USP18, and this third function of ISG15 is related, in fact, to interferon signaling itself. All right, so this story came about so we said that there's these kids in Turkey and Iran who received the BCG vaccine and developed mycobacterial disease. There was kids who were identified in China who never received the BCG vaccine. These were from one family, and they were in the clinic because they had seizures, epileptic-like seizures. And all 3 kids within one family, one of the kids actually died from seizures, and they looked to see what the problem was in these kids, and lo and behold, they were defective, homozygous mutant for ISG15, and having these seizures, they did brain scans, and they saw these intracranial thank you, Caleb, intracranial calcifications, which are typical of other interferonopathies. In other words, the loss of ISG15 seemed to be resulting in high levels of constitutive interferon production in the absence of any apparent inciting stimulus. Okay? So loss of ISG15 results in upregulated interferon signaling, and this gets to this. So that's in a nutshell the third function of ISG15, which is related to a second function of the de-isolating enzyme called USP18. So USP18, it de-isolates things, but it has a second function in binding directly to the interferon receptor on the cytoplasmic side of the membrane and attenuating, turning down signaling. So if you lose USP18, you also have an interferonopathy. And the role of ISG15 here is somehow, through its interaction directly with USP18, it stabilizes USP18 so that it attenuates signaling. So you lose ISG15, it results in a loss of USP18, and you get this hyperactivated interferon signal.
Remarkable for a little two
Crazy.
hitchhiker paper, right?
Crazy stuff.
There's going to be a quiz at the end of all of this
sorry.
that you're all going to have to take.
There actually is going to
There actually is going to be a quiz.
Well, I was just... I
John,
thought
This is a great story of a career trajectory that is, you're following your nose here.
I would say that's
And
we do follow.
I mean, are you a virologist?
No,
Careful.
I lost a job by admitting that one time, but I was not. It was unfortunately in a molecular virology department. But that's
He's on TWiV. He's got to be a virologist.
Right. Are you now, or have you ever been?
well, it's always something that's in our. We're always
John,
something we always think about.
pronounce your name again.
Huibregtse.
Huibregtse. Jon Huibregtse, thanks so much for joining us.
My pleasure.
All right, now for the final act, we have a quiz. We're going to
There is a quiz.
ask for a volunteer, and it has nothing to do with what's been said today, but we're going to ask for two people separately. So please volunteer. If you get the quiz right, we'll give you a TWiV t-shirt. Okay, this is very cool. And so please, someone volunteer.
If you've been a TWiV listener, you're likely to.
Yes, if you've listened to the show, you are likely to do very well on this
It's
quiz.
fun.
You're
It's
likely
fun.
to win a shirt.
You'll be fine.
Okay, we have a victim. Great.
All right, good.
He's been volunteered.
Yes.
All right.
What's your name?
My name is Jory Goldsmith.
Jory.
Yeah.
Okay.
Whose lab are you in?
I'm in Jason McClellan's lab.
All right. We won't ask you anything about that.
Okay.
All right, the first question is from Rich.
Right. So, what is the best way to manage a norovirus infection? A, vaccination. B, acyclovir. C, buckets, preferably 2. D, a Caribbean cruise.
Buckets?
Buckets.
Yeah.
Yeah, right. For
Alan,
those of you in the crowd who are
Second
not into
question, and
all right.
this is for the. If he gets these both right, he gets the shirt, right?
well, you got to do 3.
Oh, we got to do 3 questions. Okay,
Wait,
so
yeah.
second question. Ebola virus is named after A, a river, B, a city, C, its discoverer, Jonathan E. Bola, MD, or D, the Swahili word for scary.
I'm going to go with a river.
Yes.
Nice.
All right.
All right.
All right, the last question is from Dixon.
Let's have a drum roll here. Okay. For the t-shirt now, this is for the t-shirt, so this is very important. How many viral genome types are there? 4, 7, 10, or as Carl Sagan would say, billions and billions.
7?
Yes.
All right.
Good job.
Thanks so much.
Awesome.
All right.
You got 100%. Good job. You must be a listener.
All right.
All right. One more volunteer. There you go. Come on up. What's your name?
Victor Rodriguez.
Who do you work in?
No one's lab, just a lab in my head.
Great.
Sounds great. All right, the first question is from Kathy.
Okay, so this one, listen carefully. I'm going to ask you which of these is not a method to quantitate infectious virus particles. A, plaque assay. B, tissue culture infectious dose 50 or TCID 50. C, quantitative PCR or RT-qPCR. Or D, a lethal dose 50 assay or an LD50 assay.
Do I get a lifeline?
This is actually a tough one.
So the question is, which is not a method to quantitate infectious virus particles?
Gonna go with D.
Okay, so that was lethal dose 50 assay, and actually an LD50 assay can tell you a quantitation of infectious particles if you do it, for instance, in an animal. The correct answer, and this is why it's something that's kind of interesting, is that PCR or RT-qPCR will not tell you that you have infectious virus particles. It will tell you that you have viral DNA or RNA.
Sense.
So, okay.
All right, you got two more.
It's a tough question, I admit.
But we talk about it all the time on TWiV. All right, next
Well,
question.
it's a pet peeve of
It's a pet peeve, of which I have several. All right, here's my question. You ready?
Yeah.
What is the only cell that can take up a virus particle and replicate it? A permissive cell. B, a resistant cell. C, a susceptible cell. Or D, a susceptible and permissive cell.
To take it up and replicate it.
What was D again?
D is a susceptible and permissive cell.
I'm gonna go with D.
You got it. And the last question is from Rich.
Okay, this is a little harsh, but I couldn't help myself. You ready? This is a tough one. People who do not vaccinate their children are A, stupid, B, stupid, C, stupid, D, stupid.
Can I go with all of the above?
All of the above. Right, we
Take
got it.
that.
Right.
2 out of 3, that'll do it.
Thank you. Come get your shirt. Thank you very much. Good job.
So, Vincent, before you close up, I didn't get to do this earlier, and I clued Ray in, but I have something for each of you. And Vincent, you need to open yours last. And so that we don't have dead air on the audio, you should, when you open yours, you should describe a little bit of what you've opened. And of course, I got one for myself. So back in for TWiV 300, that's when I gave everybody their own Lego relating to something in their life. And then for TWiV 400, I gave bioartography cards. And so, Rich, describe yours.
I've got these are all like pop-up art cards. Mine has a pirate logo on the front. This is the sailing motif. Last time you actually gave me a sailor with a Lego sailor with a seagull, and it pops up with a pirate ship. This is awesome.
Right. And for Susie and Sarah and Trudy listening at home, there's also remarks on a card inside your envelope relating to a favorite audio book of mine and Rich's and Trudy's and Susie's and Sarah's.
So
It's
you want me
about-
to read this?
You could just say it's about Bloody Jack, and I told them to look for Jackie on the ship.
Excellent.
What do you got, Alan?
This is awesome. Okay, so I got a dragonfly, which is both an insect, which I'm fascinated with. I have a long history of entomology going back into my family. No, I'm not actually descended from insects, but
Eventually
yeah,
you
we've all been fascinated by insects, and it is also, of course, something that flies, which is something I very much enjoy doing. And I have a card that also features a dragonfly and a very wonderful note from Kathy. Thank you.
Very thoughtful.
What do you got, Dixon?
Well, I have a snow owl, and it's absolutely stunning, and I'm very touched and very honored. I still have my Lego, and I treasure it. It's on my desk, and I look at it every morning when I go to work, although they don't pay me anymore, but I still go to work. That's the definition of commitment. It represents all things wild, and you've actually alluded to that in your note, and so.
Well, and wise as well.
Well, that's very kind of you. It's very kind.
All right.
Thank you so much.
So I haven't opened mine yet. So
Okay, and it's pink.
Pink.
That might give you a clue.
Oh, this is great.
let's see what we got here. My favorite tree, a cherry cherry blossom. And I complain on TWiV about people going to see cherry blossoms all the time. And a nice note. Do you want me to mention this? No?
Sure. You don't have to
What
read
you've
it,
done
it's
with,
part of it.
with science podcasting is beautiful, much more than the lovely cherry blossoms.
Oh,
Thank you. Thank you very much.
thank you.
And these will go with the Legos.
Right.
Absolutely.
And I got myself a snowflake tree. So
Awesome.
All right, I know we've kept you a long time. Can we do picks really quickly?
Yeah.
Picks are
Quickly,
a
Dixon.
staple.
I will.
What is your pick, Dixon?
It's from it's Cosmos magazine. The recent edition had an article about the 5 extinctions, but with stunning photographs of examples of organisms that disappeared at each of those extinctions. So I highly recommend just scanning it. It's an easy thing, coupled with a song from the album called The Living Sea, and it's a lead song by Sting, and it's called Fragile. And if you look at the images and play the music, I think you'll be touched, just like I was.
Thank you, Dixon. Alan, what do you have?
I have a paper that I read just recently. Somebody was sending this out on Twitter, and I thought it was just really, really cool. It's the airplane cabin microbiome.
Great.
Which is just, people have been doing the microbiome of fill in the blank. And so these folks took 10 transcontinental flights and took microbiome samples. And they found, very much like the subway, the inside of an airplane is covered in skin. So it's the skin microbiome mostly, but there were variations. There was significant variation from flight to flight. It's a neat paper, and it is open access. So
Cool. Thank you. Rich, what do you have?
So I have no idea where I came across this, but I have a link to an interesting organization called the Coalition for Epidemic Preparedness Innovations, which is an organization that, as I understand it from reading their site, probably arose in response to the Ebola epidemic, the big one in 2013, 14,
we might have
15.
mentioned that on the show.
What, the Ebola?
The Ebola
Yes,
epidemic,
we did. And they're trying to address the situation of, why aren't we ready for some of these big things that come along with a vaccine? And they're trying to stimulate research into those things. And it's they're looking at several different emerging diseases. They're funded by the Wellcome Trust, Bill and Melinda Gates Foundation, several nations, and they look and fund at proposals. And they've invested close to $100 million in.
Wow.
So that's real money. Okay.
And these links, by the way, are all in the show notes online, so you all can get them very easily.
Microbe.tv. Kathy, what do you have?
So we have an arc on the show that's science art, and this one is a new site to me that my friend Sarah told me about. It's Redbubble, and I found one that's a phage-specific scarf. So it relates to yesterday's TWiV that we did at another university in Texas. And then I have the general link to, if you just Google on the Redbubble site for virus scarf, you get a variety of scarves and some other things as well, but some of them are really beautiful. So redbubble.com, I think it is, and then virus, and you'll find these
Very cool.
scarves.
Cool. Thank you. So my pick is Lewis Mackenzie's article. You can find it on bioRxiv, so everyone can see it. It's in review, I believe. It's called Science Podcasts, Analysis of Global Production and Output from 2004 to 2018. I mentioned it earlier, so I won't spend too long, but I note that in the introduction to the paper, he says, due to their global distribution, podcasts can cater for niche and highly specialized audiences. For example, This Week in Virology, which serves the virology community, which is true, but you're only 30% of our listeners. 70% are not scientists. And then one more quote from this. Let me see if I can find it. He says, podcasts, yes, many styles of podcasts have been created because they're unconstrained by the style and the time demands that typically restrict traditional broadcast TV and radio media. Because of this varied and decentralized production, it could be said that there's a science podcast for everyone. I really like that, a science podcast for everyone. So that's Lewis Mackenzie. We have a listener pick from Maureen, a great way to encourage young scientists. She sends a video about a 12-year-old who is taking on Flint, Michigan's water crisis.
Awesome.
12-year-old kid doing that. It's really, really
Great
cool.
video.
And that is TWiV 500. It's not the longest TWiV we've done, but it's up there. And you can find all of them at microbe.tv/TWiV. We love getting your questions and comments. Some of you here in the audience have sent in questions and comments. We love it. TWiV at microbe.tv. If you love what we do, consider supporting us over at microbe.tv/contribute. We have a page with different ways you can do that, including Patreon, where you can give us a certain amount of money each month to support our travel and our expenses and so forth. Just a few comments on the future of TWiV. So we've been doing this for 10 years, 500 episodes. The next one I want to celebrate is 1,000. I don't want to do 600 or 7 or 8 or 9. 1,000. That's 10 years from now. It is a long time, and who knows what happens in the meantime. I have been 10 years without missing one episode for any health reason. I am really lucky that I've been able to do it every Friday for 10 years. I don't know if that'll continue. So my goal for the next 10 years is to build an organization that can go on in perpetuity. All right? I need to put an organization together that can do this, because right now I have great co-hosts, but I do most of the tech, and that's not right. So it's my goal in the next year or so to make TWiV and all the other podcasts into a nonprofit and try to establish funding that we can establish a board and get people to bring this forward so that if anything should happen to us, it keeps going. And the reason I'm doing that is because you and other listeners have said you like it. So I think it's worth perpetuating. So that is our goal. Today's guests have been from Immunize Texas, Jinny Suh. Thank you so much for joining us. From the University of Texas, Jason McClellan. Thanks so much for joining us. And from the University of Texas at Austin, I've already forgotten how to pronounce your name. Who? Huibregtse.
Huibregtse.
Thank you for joining us, Jon. TWiV is Dixon de Paume. Thank you, Dixon. Verticalfarm.com, parasiteswithoutborders.com, and thelivingriver.org. Thank you, Dixon.
You're welcome. This was great.
Let's see, who's next? Rich Condit is an emeritus professor at the University of Florida in Gainesville, currently residing in Austin, Texas. Thank you, Rich.
Thank you, and I want to thank the audience, okay? We have a lot of local TWiV listeners here, and they all showed up, and it's just terrific.
Kathy Spindler's at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This is a lot of fun.
Alan Dove is at turbidplaque.com. You can find him on Twitter as Alan Dove. Thank you, Alan.
Thank you. It's always a pleasure.
Sincere thanks to all of you for doing this week in and week out. It's really amazing.
And thank you.
I'm Vincent Racaniello. You can find me at virology.ws. My thanks to Chris Sullivan for organizing this, the John Ring LaMontagne Center for Infectious Disease, the John LaMontagne family for the support of the center, and the University of Texas, Austin for hosting us for TWiV 500. And of course, thanks to the audience. I also want to thank ASM, the American Society for Microbiology, for their support of TWiM, and our producer, Ray Ortega, who's been manning the camera. Ray helps us out. He's been helping us out over the years, for about 10 years now, with our various podcasts. The introductory music is by Ronald Jenkins. He's at ronaldjenkins.com. And the last thing now we have to do, we have a few t-shirts here we'd like to toss to you, and I've used mine up, but Dixon, Alan, Rich, and Kathy, you can toss yours out. So go right ahead,
Okay.
yours are over there.
So being in Texas, we've been practicing our football tosses here. Going to see what kind of range we can get. Oh, a fight in the stands. There are more coming. There are more coming. There are more coming.
I'm using the knotted t-shirt approach.
That's a good idea.
I'm using the throw it backwards approach. Right again. Have another.
A little less height, a little more range. There you go.
From the women's softball finals.
That was actually
Dixon.
really good.
Dixon, good one. That was a good one.
The behind the back. Oh. Who's going to get it?
in the aisle.
One more. This has got to reach the back row.
All right.
You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.
That was great. That was just